A study based upon the mechanical and durable properties of concrete using sugarcane ash, marble waste powder and recycled aggregate as partial replacement of OPC, fine aggregate and coarse aggregate respectively. The demand of utilization of the waste product from the industries is at its peak, therefore, several experimental investigations have been carried out to examine their physical and chemical properties when they are used as a replacement material in concrete. This led to the revolutionary techniques which achieved high strength parameters. The crushed concrete is the most impeccable technique to produce the recycled aggregate. It can also be derived from any kind of concrete debris. The main advantage of recycled concrete aggregate, RCA, is that it resembles the same properties as that of concrete. Sugar bagasse ash, SBA, is the burnt byproduct of sugarcane's bagasse. It is very fine and it becomes the main advantage of bagasse ash. Another type of replacement material is marble waste powder and it is derived by cutting and polishing the marble. In the present experimental study, which was conducted in an attempt to utilize these waste product, design mix of concrete was designed by partially replacing cement with bagasse ash, fine aggregate with marble powder and coarse aggregate with recycled concrete aggregate at varying proportions. Different tests were conducted in order to evaluate and determine its strength parameters. The conclusion which was made for the present study is that the compressive strength and flexural strength tends to increase at the beginning and gives maximum value for the design mix containing 20% SBA, 20% marble powder and 25% RCA, and after this the strength starts to fall. The maximum split tensile strength was achieved with the design mix which entails 20% SBA, 40% marble powder and 25% RCA, whereas other mixes give satisfactory result. Keywords: sugarcane bagasse ash, marble waste powder, recycled concrete aggregate. Introduction. The exploitation of natural resources is defined as the overusage of natural resources for the development of nation or an individual, but it entails negative effects on environment. The usage of raw material is mainly in the manufacturing industries where extraction and processing of the same is done in order to make the material useful in daily life. In modern world, 80% of the world's energy consumption is obtained by the extraction of fossil fuels, which entails oil, coal, and gas. Similarly, the production of concrete every day is skyrocketing and the raw material, cement, sand and aggregate, is being exploited in this process. In the beginning, the production of concrete was limited, but obliviously, man has led to the exploitation of these natural and raw resources as with time, the need for concrete increases with the advancement of infrastructures. Today we are standing at the verge of the modern techniques of construction, but the cost of this advancement is degradation of environment. Green concrete. Now, mankind has realized these serious issues, problems, and agendas. New development methods and techniques have been developed since the last decade and alternative measures have been introduced. More and more research work is being carried out every day so that the tackling to these problems becomes easy. Many alternatives or substitutional waste or byproduct of various material to raw and natural material has been introduced in concrete industries which reflects same strength and results as original but with the advantage of cheap and eco-friendly. The concrete which is prepared by using waste or byproducts is called green concrete. With the help of green concrete, sustainable development is being achieved now. Any structure designed or constructed in such a way that it minimizes the utilization of natural resources for the construction process is called a sustainable development in construction industry. It is an impeccable gift for present and future to the earth when sometimes, the concrete is made with its own waste, debris, which is eco-friendly in nature. Green concrete has proved to be a perfect tool through which the environmental impacts have been reduced. Energy saving, reduction in CO2 emission, usage of wastewater and materials are one of the main merits of using green concrete. Materials like fly ash, rice husk ash, bottom ash, or bagasse ash, marble powder, glass powder, recycled aggregate are the most common and backbone in the concept of replacement of raw material in concrete. The usage of the same in concrete was one of the revolutionary invention which is saving this planet. Partial replacement and fully replacement of the raw and natural material with waste or recycle material is done to generate the more strength concrete. Materials and methods. Cement. The cement was ordinary Portland cement of grade 43. Cement is normally manufactured under controlled and supervised conditions. The cement is tested for consistency test, setting time test and specific gravity test. The characteristics of the cement used in this experimental work are represented with the table. Aggregates. Coarse aggregates and fine aggregates are collected from local source. After collection, the aggregates were tested in the laboratory to check the quality on various parameters. Fine aggregate. Crushed sand was used as fine aggregate. Sieve analysis was done to determine the zone of sand as per the guidelines of IS 383-1970. Physical properties of sand such as specific gravity, fineness modulus were calculated. All the physical properties as well as results of sieve analysis are shown in table below. Coarse aggregate. Grading of coarse aggregate was carried out according to IS 383-1970. Crushed aggregates used were angular in shape. Nominal sizes of aggregates were 20 mm and 10 mm which were combined to get new graded coarse aggregate. Specific gravity and water absorption of coarse aggregate were determined as per IS 2386, Part 3, 1963. Detailed sieve analysis test of coarse aggregates was done for new combined graded aggregate and results have been shown in table below along with its physical properties. Table 4 sieve analysis of graded aggregates. Water. Potable water available in the laboratory for mixing and curing was used for this project specification conforming to BIS 456 2000. Recycled concrete aggregate. One of the most impeccable alternative to raw material is concrete aggregate, RCA, which is obtained from construction and demolition, C&D, wastes, which results in protecting the natural resources and land, avoid environmental pollution, and reduce the overall charges of construction. The utilization of recycled concrete aggregate in structural construction is practiced in many countries. Various techniques of processing the wastes, effects on the properties of concrete are to be explored. The properties of recycled concrete aggregates are mentioned in table. Figure 1 Recycled concrete aggregate at Chandigarh Highway. Sugarcane bagasse ash. Sugarcane industry is one of the leading industry as the demand of sugar is huge in the country. The end product of extracting the sugar from sugarcane is bagasse. The bagasse is a very useful waste as it is used in the boilers in burning process. The ash which is left behind after the burning is called sugarcane bagasse ash. SBA has high utilization in concrete as it can be used for replacing cement due to its fineness. The properties of SBA can vary with its source as it depends on how the bagasse is burned. The properties of bagasse are mentioned below in the table. Marble waste powder. Marble waste powder is yet another waste product of marble industry which has been proved useful in replacing the fine aggregates in concrete making. Marble waste powder, MWP, is derived as the result of polishing and cutting process of marble. This byproduct cannot be used further in marble industry and is useless to them. Therefore, researchers have found a way to utilize this waste product in concrete as an alternative to fine aggregate in order to reduce the cost of concrete and environmental pollution. The properties of marble waste powder have been represented in table. Marble waste powder. Tests and results. The results which were recorded during the study entitled to study the strength parameters of concrete using sugarcane bagasse ash, marble waste powder and recycled aggregate are mentioned as under. Compressive strength. Reference concrete mix and replacement concrete mix cube samples, size 150 mm x 150 mm x 150 mm, were tested under compression testing machine. The specimens were prepared as per the codal provisions and tested for its compressive strength at 2 curing periods, that is 7 and 28 days. The results obtained from the tests are represented as under in tabular and graphical form. With the addition of waste and recycled material, an improvement is seen in compressive strength. In the beginning, the strength increases as the percent of replacement of bagasse ash, marble waste powder and RCA till mix M3 as M3 attains the compressive strength of 36.45 MPa. But after mix M4, the compressive strength tends to decrease till mix M6. Minimum strength was found out to be 32.15 MPa for mix M6 at 28 days. All the mixes show little variation with respect to each other. But variation in M3W.R.T reference mix is high as there was an increase of 4 MPa approximate in its strength. The bar chart given below is showing the variation in the result of compressive strength of the test samples at 7 and 28 days. It is used for comparison purpose. Compressive strength result bar chart. Split tensile strength. The split tensile strength of concrete is one of the basic and important properties. Splitting tensile strength test on concrete cylinder specimen, size 150 mm diameter and 300 mm height, is a technique which is used to determine the tensile strength of concrete. As concrete is very weak material while resisting tension. This is due to its brittle nature and it does not allow resist the direct tension. Experimental results of split tensile strength test at the curing period of 7 days, 28 days are given in the table below. These values are also represented graphically in fig below, which is used to represent the variation of strength values in comparison purpose between the various concrete mixes. Results of split tensile strength test of specimen. It is concluded that the average tensile strength of the given specimen varies with the different proportion of replacement. The variation in results of split tensile strength at 7 days and 28 days is represented in fig below. Maximum split tensile strength of 3.12 MPa at 7 days and 4.46 at 28 days can be seen for mix M4. Whereas, the control mix shows the minimum strength at both the curing period. Again, the variation between these values is not large and the pattern of increase and decrease in strength resembles zigzag pattern. Split tensile strength result. Flexure strength test. Flexural strength test is a method which also measures tensile strength of concrete. It measures the strength of an unreinforced concrete beam against the failure in bending. Test results of flexural strength test at the age of 7 days, 28 days are given in the table below. Concrete mix M3 showed maximum flexure strength among all other concrete samples. The test results reflect that the average flexure strength of the specimen increased till concrete mix M3 and then it tends to decrease with the increase in the percentage of replacement. It was concluded from fig below that the M3 mix shows higher flexural strength of 5.61 MPa at 28 days than other design mixes, and M6 mix has minimum flexural strength of 5.23 MPa at 28 days. The variation in flexural strength is slight for all the mixes at both the curing period, i.e. 7 days and 28 days. Flexure strength test results. Ultrasonic pulse velocity test. UPV test is an in situ, non-destructive test which is used to check the quality of concrete at a specified given period. With this test, the strength and quality parameter of concrete is calculated by measuring the velocity of a pulse of ultrasonic which is sent through a concrete structure or sample, and time taken from starting point to end point is measured. If the velocity is higher, then the quality of structure is good. GR6 ultrasonic pulse velocity outcomes. Rebound hammer test. Rebound hammer test is a method of non-destructive test of concrete that measures a convenient and quick indication of the compressive strength of concrete structures or sample at a specified time. The hammer which is used in this test is called a Schmidt hammer, which entails a spring-controlled mechanism that slides on a plunger enclosed in a tubular shell. Conclusion. The present experimental investigation study was carried out preparing the design mix, reference mix and replacement mix, of grade M30. The partially replacement of cement with bagasse ash is done from 10% to 30% with the increment of 10%. Marble waste powder was used in a proportion of 20% and 40%. Coarse aggregated was partially replaced with a fixed proportion of 25% with recycled concrete aggregate. After performing this study and comparison of the results, the inferences that were drawn for the present study are discussed below. The compressive strength and flexural strength gradually increases till the concrete mix M3 and then it starts to decrease till concrete mix M6. The compressive strength and flexural strength of concrete was found out to be maximum for the concrete mix containing 20% bagasse ash, 20% marble waste powder and 25% RCA, i.e. 36.45 MPa and 5.61 MPa respectively. And minimum strength is shown by the concrete mix M6, 30% bagasse ash, 40% marble waste powder and 25% RCA, i.e. compressive strength of 32.15 MPa and flexural strength of 5.23 MPa. Therefore, it can be concluded that all the replacement mixes showed better results than control mix except for the concrete mix M6. Whereas, the split tensile strength of concrete increases till the concrete mix M4 and then it starts to decrease till the last concrete mix, i.e. M6. It was found out that the maximum split tensile strength, i.e. 4.46 MPa, was observed for concrete mix M4, which entails 20% bagasse ash, 40% marble waste powder and 25% RCA. Moreover, the minimum split tensile strength, i.e. 3.87 MPa, was observed for control concrete mix. Therefore, it can be concluded that all the replacement mixes showed better results than control mix. Test results of ultrasonic pulse velocity and rebound hammer indicated that concrete mix M3 shows the higher values than any other concrete mix. Maximum values of ultrasonic pulse velocity and rebound hammer was 4.6 and 51.42 respectively. In the gist, the optimum proportion of various replacement material is 20% bagasse ash, 20% marble waste powder and 25% RCA, as it gives higher values for the present study.